So question 7 starts off with a lovely little one with finding out what k is, isn't it? Look, 4k must be 0.6, and so k is going to be 0.15 each time, isn't it? So 0.15, 0.45, just using the fact that the probabilities add up to 1. Let's use the calculator to find out what the mean and the standard deviation of that set of data is. So I've got 0.1, 0.45. And you could be doing this quicker just by doing multiplying them all together. So the mean is xp and finding out the variance in the usual way. Didn't mean to do that. Calculations, one variable calculations. So I've got that the expected value of x here is 2.85, and I've got that the standard deviation is 1.5898. And I'm going to go back to menu 1, and I'm going to bring that up. Options, not options, variables, statistics, x, standard deviation, and I'm going to square it and put that into a letter. And so I now know what my variance is going to be when I go on and do this. So we're doing a sample of 100, and we're going to need to use the central limit theorem, because we're not starting with a normal distribution at all, are we? But the sample of 100 will have a mean of 2.85 like it was before. That won't change. And now the variance will now be 1.5898 squared divided by 100, because we're doing 100 of them. Use the central limit theorem to estimate the probability that the mean of these observations is greater than 3. Find out the probability that the mean of these observations is greater than 3. Back with the calculator. Into the distributions menu. We're doing a normal distribution greater than. We want it greater than 3. We know what the mean is. The mean was 2.85. And the standard deviation. The standard deviation is the square root of, do you remember we put the variance in A? And I'm dividing that by 100. And so there's my standard deviation there. Basically, I've just square rooted that, but without tapping it all in. And so the probability that it is greater than 3 is 0.1727. And looking at that, exit. Looking at that just to see if it's okay, 17271, all good. Comment on the accuracy of your estimate. It is only an estimate. We did use central limit theorem, so it is only an estimate. But because n is very large, but n is 100, so it should be quite accurate. By the time you've got to numbers that big, I would say that is going to be pretty close.